Hello and welcome. My name is Vikila here. In this short tutorial, we're going to examine some formulas that have to do with our power, our voltage, our current, and resistance. I'm just gonna show you on the circle here what we're doing here, and here we go. Let's define our parameters here. The first parameter that we have is P, is what? Power. That's the power, okay? And the next parameter is V, is the voltage. And the other parameter is I, is our current, and R is our resistance, okay? So, in this circle here, we got a circle with quadrants, 4 quadrants. And each quadrant is divided into 3 parts, okay? So, this being the first quadrant, second quadrant, third quadrant, and fourth quadrant. Okay, the quadrant, as you know, is just you have divided the circle into 4 equal parts. Okay, so this quarter here, we have voltage, and in this quarter here, we have our power, and in this quarter here, we have our current. And in this quadrant here we have our resistance. So let's work out. Let's start from the voltage. Our voltage is equal to I times R, which is your current times your resistance. That gives you your voltage, and your voltage also is equal to power divided by current, okay, and your voltage also is equal to the square root of the resistance times the power, okay. We'll derive some of these ones from the power, and then let's come to resistance. Resistance is equal to voltage over current. It actually derives from this one here, because we have seen. In this one, we've seen that I times R is equal to V. So if we want to get the resistance here, we just make our R the subject of the formula. So we divide both sides by I. So divide by I. So we get R is equal to V over I. That's that one there. And P, R is also P over I squared. We'll derive that one shortly. And let's go to this one here. R is also equal to V squared over P. V squared over P. We'll also derive that one shortly after we know the power thing. And then let's go to current. Current, there's one thing that we want to derive on current. We have known that voltage times R is equal to, current times R is equal to voltage. So we can quickly derive here. We have known that. Let's erase this one. So we've known that I times R is equal to voltage. So this is I times R is equal to voltage. So let's make I the subject of formula. I is equal to, we divide both sides by R. So I is equal to V over R here. That's what we have here. I is equal to V over R. And let's go forward a little bit. We have known that we'll derive this one as soon as we finish that one. So I is also equal to P, power over voltage, and I is also equal to the square root of power over resistance. Now let's go to power. Power. After we do the power, we'll derive all the other formulas. Power is equal to, so the first equation with power is equal to voltage times current. Voltage times current is equal to power. Now voltage times current is equal to power. That's that one there. Voltage times current is equal to power. Okay. Now what we can do in this formula here, we know that I is equal to is equal to V in this V over R. That's what we know. You know that. So we can put power. We can substitute this one here into I there. So it's got V times V over R, which is equal to V squared over R. So we got that formula there, V squared over R. So power is equal to V squared over R. Where are we? Here is the thing. Okay, now let's get this one here. What does it say? We want to derive that one there. So we know that I times IR is what? Voltage. Now we can make which you found out there. I times R is equal to voltage. So we can actually remove the V there and P. So P is what? V times R. Because hang on a little bit. Well, we made a mistake here, so let's start again. So I want to substitute V into there. So power is equal to I squared, which is I times R times I, which is what I squared R. That's our power there. Okay. So we got all the three formulas. Now the other one there, which is this one here, V is equal to R times P square root. So you get this one here. Remember where we said power is equal to V squared over R. If we make V the subject of the formula here, you find V is equal to, we multiply both sides by R times R here, and let's put V squared is equal to R times power. We take square root here, so square root of V squared is equal to V is equal to square root of R times P. Okay, so we get that formula there. Okay, the other one, which is P over I, we know that power is equal to voltage times current. Therefore, if we make V the subject of formula, you find we have to divide both sides by I. Therefore, we get V is equal to P over I. And you get that. Okay, let's go down to that. Now let's get down to these formulas for resistance. Let's say we know that I times R is equal to V. So let's put V there. Let's put V there. So P is equal to I squared times R. We have just substituted V by this one here. So let's divide both sides by R and both sides by R. We get I squared is equal to P over R. And let's take square root. Square root of I squared is I, and then square root of P over R. Now you get we're getting I is equal to square root of P over R here. There we go. Now let's go to the other one, which is still on the same. You can actually do this. If you want to find the resistance, you can actually divide both sides by I squared, then I squared, then you find R is equal to P over I squared, which is this formula here. And let's go to this V squared P. V squared P. V squared P comes from this. Comes from this fact. We know that V is what? I times R. Now, what we want to do, we want to remove I from there. So we divide both sides by R, so that we have I is what? V over R. Now we substitute this I by that, so that power is equal to V times V over R, which is V squared over R. P is equal to V squared over R. Now, what we can do to get, we cross multiply. In fact, here we divide by P, that's cross multiplying times R here, times R. So we get R is equal to V squared over P, which is that one there. And that's your formula there. And which one is left now? This one is left. Oh, we have done that. So that's about it. That's about it. If you, this one here is pretty simple because you got that P is what. Let's take that. P is what VI. P is what VI. We're in the current thing. Make current subject of the formula. Therefore, you divide both sides by V, and then you get I is what? P over V. That's it. There we go. So those are the formulas for power, and I urge you to look at them. And the quadrants, I've labeled the quadrants here as this quadrant here, which is I, it's a current quadrant, and this is a power quadrant, P. In that quadrant there is a voltage quadrant, and that quadrant there is a resistance, which is that. So quadrant number 1, quadrant number 2, quadrant number 3, and quadrant number 4. You can change them however you wish. Yeah, you can change them however you wish. But the other thing that you have to notice there is if you can actually create a nice thing where this goes into quadrant 1. But we'll get that in another lecture, because it's a nice, I've just discovered here there's another thing that you can do to enjoy this cycle here. So thank you very much. We're going to use these formulas in power systems and some simple calculations where we might want to know what current is flowing, or what voltage is impressed there, or what's the power, or what's the power losses, that kind of stuff, or what's the transmission, the receiving end voltage, or something like that. We might want to use these formulas. So these are the formulas, the grand formulas that you use in power systems, in many analyses. Very simple formulas from physics that we learned a long time ago. Yeah, they can become very handy in solving a lot of problems. So I want to thank you very much. My name is Vukile, and we meet you in the next program, where I'll be discussing electrical engineering, some tidbits here and there, so that we get to understand practical things that happen in the field there. Thank you very much. I'll see you later. Bye.